Now for the 2020 10B problem 14, which was also the 12B problem 11. As shown in the figure below, 6 semicircles lie in the interior of a regular hexagon with side length 2, so that the diameters of the semicircles coincide with the sides of the hexagon. What is the area of the shaded region? This is shaded, just pretend. Inside the hexagon but outside the semicircles. Probably the number one feature of a regular hexagon is that it's 6 equilateral triangles, at least in my opinion, number one feature. So we can take advantage of that. If we were to cut through here like this, and like this, and like this, you can see that each of the 6 center regions that are shaded in the original problem, each of these regions is equal. And we can just analyze one of them and multiply it by 6 to get the answer. So if I take an equilateral triangle and I construct a semicircle on the edge of it, then I want this region at the top that's inside the triangle but outside the semicircle. So how are we going to attack this? Again, with circles, you oftentimes want to add an advantageous radius somewhere. So if you just start from the center and you think about it, these are all 2, this will be 1 and 1. If I draw the radius here, this will be 1. And if I draw the radius here, this will be 1. And we know that this angle is 60 already, so this will be 60 as well because it's isosceles, and therefore this is 60. Then you know you have 2 60-degree equilateral triangles down here with side length 1. And what's this in the middle? Well, since this is 60 and this is 60, it's a 60-degree sector. So again, we're going to use S, which stands for side length, squared root 3 over 4 for the area of an equilateral triangle. The big equilateral triangle is got side length 2, so 2 squared over 4 will cancel. We're going to get root 3 minus, and now we have to subtract the parts we don't want. We can just do these 2 equilateral triangles, which are also s squared root 3 over 4, but s is just 1 this time. So it's going to be 1 root 3 over 4, or root 3 over 4, but there's 2 of them. So 2 times root 3 over 4 is root 3 over 2. Plus, we also have to add the sector in the middle. Now, sector area is simply the central angle over 360 times the area of the circle. So 60 over 360 is 1/6. Pi r squared, our radius of the sector is 1. We just don't need to worry about the radius now. Pi over 6 is that sector. Now, I'm going to subtract. This is like x minus a half, or 1 minus a half. It's going to be root 3 over 2, because if you have 1 minus a half, or root 3 minus root 3 over 2, you get root 3 over 2, minus pi over 6. And then we're simply, that's only one of the triangles. We've got 6. We're going to multiply. This gives 3 root 3, and the 6's cancel here also, minus pi. That is answer choice D. All right, we're back for the 2020 AMC 12B, problem number 12. This video is recorded with some new equipment. Hopefully it resolves the sound issue I was having on past videos where you were getting sound in the background or some kind of mic effect. It's hard to explain what happened, but it's better now, I hope. Let AB be a diameter in a circle of radius 5 radical 2. Let CD, so before we even continue, let's try and make this. Let's make a circle. We'll give it a diameter of AB. Actually, make it more like this. Erase that part. Okay. And it says CD is a chord in the circle that intersects AB at a point E, so that BE is 2 root 5. Well, root 5 is about 2.1, so 2 times 2.1, about 4.2 or so is what BE is. This is an approximation, but we know that to the center of the circle, which we're going to call F, that BF will be equal to 5 root 2, and root 2 is about 1.4, so 5 times 1.4 is about 7. So we know that E is about right here, approximately, so that this is a little bit past the halfway point to BF. And it also says that angle AEC, that's from A to E to C, is 45 degrees. So if I went straight down, this would be 90. I need to split that and come about like this. So then C will go here. AEC then being 45 degrees. This little angle in here is 45. And it's going to keep going till it hits the circle over here, where this will be D. And now it wants to know, what is CE squared plus DE squared? Okay, so how are we going to approach this? We have a few options at our disposal. First off, we know that BE is 2 root 5. And that means that EF is equal to 5 root 2 minus 2 root 5. That's EF. Now, how can we use that? Well, we have a 45 degree angle. We should be thinking of what we can be doing with the 45 degree angle. Well, if we were to take from F, that I'm calling the center of the circle F, and we come directly over to C at 90 degrees, to CD at 90 degrees. This is a line from the center of the circle intersecting a chord at 90 degrees. It's guaranteed to bisect that chord. We'll call this G, just for the next letter up. Okay, so what happens is we get a 45, 45, 90. So that FEG is a 45, 45, 90. And the way we can think of it, we know that FE, or EF, is 5 root 2 minus 2 root 5. And we could easily divide this by root 2 to get both FG and GE. And so if we wanted to do that, we could, but let's hold off for a second. Let's call GE something like Y, and then FG will be Y. And we'll let GD equal CG. CG and GD are bisected because FG is perpendicular to CD. It's guaranteed. It's a theorem in geometry. So CD equals, or GD equals CG is going to equal X. And that makes DE, since GD is X, DE is X minus Y, and CG, again, CG is X. So we have X right here. Now we're looking for CE squared plus DE squared. Well, the thing is, how are we going to find, even if we wanted to find the length of X, these are actually, again, equal. What we could do is connect F to D. And connecting F to D is a radius, so we know that FD is equal to 5 root 2. And what we have created now is a big right triangle where GD is X, and we can find Y from this if we want to. But before we go all crazy finding Y, let's just write what we need in terms of X and Y. And maybe there'll be a shortcut. Let's go. CE squared. CE is X plus Y, right? Because X is to here and Y is this part here, GE. So we have X plus Y squared plus DE squared, and we've already labeled DE as X minus Y. So X minus Y squared. This is what we want. If we square this, we're going to get X squared plus 2XY plus Y squared plus X squared minus 2XY plus Y squared. So nicely, the XY's, 2XY's cancel. You have 2 times X squared plus Y squared. Now, keep in mind, X squared is this length right here, or X rather is this length right here, and Y is this length right here. So what does that give us? If this is X and this is Y, then this is the square root of X squared plus Y squared, right? And so if we want to find X squared plus Y squared, we just need the hypotenuse squared, right? And so the hypotenuse for us is 5 root 2. So X squared plus Y squared equals 5 root 2 squared, which is 25 times 2, which is 50. And then we have the 2 out front. So 2 times 50 is 100. And the answer is E. And this is the 2020 AMC 12B problem number 13. Which of the following is equal to the square root of log base 2 of 6 plus log base 3 of 6? Not a whole lot here to do with the answers. Just go to this and start working with it in some capacity. You should know the rule that log base b of x times y equals log base b of x plus log base b of y. And since 6 is actually a 3 and a 2 combined, 2 times 3, we can split this into the square root of log base 2 of 2 plus log base 2 of 3. Furthermore, we can do the same thing with this one. It becomes plus log base 3 of 2 plus log base 3 of 3. Now, log base 2 of 2 is 1 and log base 3 of 3 is 1, so we can combine those to get 2 plus log base 2 of 3 plus log base 3 of 2. Now, it might not be commonly known, but you should, well, change of base formula should be known. You should know that log base 2 of 3 can be made log base b of 3 over log base b of 2, where b is anything you want it to be. But what that means is that this could also be placed in the same base, and it would be log base 3 of 2 equals log base b of 2 over log base b of 3. If you'll notice then, these are reciprocals. So we could call x log base 2 of 3, and then log base 3 of 2 would be 1 over x. That's the part that's not commonly known, is that these are reciprocals, but you can see it using change of base formula. So now we'll have the square root of 2 plus x plus 1 over x. And you might be like, what are we going to do with that? Well, there's some options actually. If you completed volume 1, there were some manipulations where you would multiply things like x plus 1 over x squared. And if you did that, you would get x squared plus x times 1 over x times 2 plus 1 over x squared. In volume 1, that took place. And so you'll notice that the x times 1 over x just goes away and you get 2. You get 2 plus x squared plus 1 over x squared. Now, that looks a lot like what we have. We just don't have squares. So what we could do, if you can just think of it as root x squared if you wanted to. And so then, or if you makes it easier, you could say x equals u squared. Make another substitution. And then let's do the other substitution. You'll get u squared plus 2 plus 1 over u squared. Okay, the reason you want to do this is you can factor it. You can go back from this back to this expression. And so we can factor this as the square root of u plus 1 over u squared. And then the square root of the perfect square, binomial, will cancel out and you're left with u plus 1 over u. But what's u? We just have to square root to get it. U is going to equal the square root of x. And so this expression will now be root x plus 1 over root x. And there's another little trick here, because we know that x is log base 2 of 3 and 1 over x is this. Well, we have 1 over root x, but since this 1 is its own square root, we could put this like this and call it root x plus the square root of 1 over x. And since x is log base 2 of 3, this becomes the square root of log base 2 of 3 plus 1 over x is log base 3 of 2. You get the square root of log base 3 of 2, and that matches answer choice D. All right, and this is the 2020 10B problem number 16, which was also the 12B problem 14. Bella, maybe it's Bella, I don't know. Bella and Jen play the following game on the closed interval 0 to n. If you don't know interval notation, I'm not going to unpack the whole thing here. There's many videos explaining it. Probably Khan Academy has one. The basics are that the brackets mean you include the endpoints, so 0 and n included, and parentheses in place of them would mean you don't include the endpoints. It's not an ordered pair. Of the real number line where n is a fixed integer greater than 4, so n greater than 4, they take turns playing with Bella going first. At his first turn, Bella chooses any real number in the interval 0 to n. Thereafter, the player whose turn it is chooses a real number that is more than 1 unit away from all numbers previously chosen by either player. A player unable to choose such a number loses. Using optimal strategy, which player will win the game? There's various options over here. Let's just try something out. To be honest, under test conditions, I don't think I would have got this. It took me a little while to get it. I probably would have had to skip it, maybe come back at the end. I don't really know for sure. I was able to get it later. Start with n equals 5, because it has to be an integer greater than 4. So now you have this interval from 0 to 5. Okay, now Bella's going to go first. What would be the optimal strategy? We don't really know. Try doing some trial and error, see what happens. Let's say, whatever, it doesn't really matter. Bella chooses, 4.9. Then Jen goes and she chooses, 3.89, because that's more than 1 unit away from 4.9. Then Bella goes and she would choose, let's say, 1.5. Then Jen's going to go and she chooses, there's still a gap between 0 and 0.5. Jen can choose something in there. There's also a gap from 2.5 to 2.89 that exists. So Bella can just choose 2.6 and then Bella will win. Is this optimal? Probably not, but just kind of do something to get an idea for what's happening, how the game mechanics work. This is where you kind of have to have an epiphany, and it has to come across. I don't know how you think of it. You just kind of think of it on the spot, but eventually you might try something like, what if Bella chose the midpoint, right? What if Bella chose a midpoint? If Bella chose a midpoint, it would leave 2 intervals for Jen to choose in. 0 to 1.5 not inclusive, or 3.5 not inclusive to 5. Now, Jenna's going to have to pick a number in one of these intervals. If she picks a number that eliminates this interval, like say she picks the midpoint, 0.75, then nobody else can pick in this interval anymore, because if she chooses 0.75, you can't choose 1.75 or 1.76 because it's more than 1 away from here, but less than 1 away from here, and you can't choose 0 because it's not more than 1 away. Now, Jen could choose a different strategy as well. We'll get to that in a second. If Jen does this and blocks out this interval, then Bella does the same thing in the other interval, choosing 4.25 or something similar. Okay, so what if Jen didn't block the interval, though? What if she chose 1.49, right? If she does that, now there's still 0 to 0.49 not inclusive that Bella can pick on for that interval. Okay, you might think, well, maybe Bella should choose something in that interval then. If she does, Jen can block the other interval and win. So Bella's not a good idea to choose something here. Instead, what if Bella chooses the exact same value that would be the equivalent value on the other side? So if she chose 1.49, just 0.1 below, 0.01 below this, she can choose 3.6 or 5.1, something like that, that is past 3.5. Now, this is going to have an interval left of 4.51 to 5. So again, there's still 2 intervals, but now it doesn't matter what you choose. Once you choose, it ends the interval. So whatever Jen's going to pick, Bella takes the other interval, and then Jen can't choose, and Bella wins. So what we notice is that when Bella chose the midpoint, she won this game with the 5. Now, she won this one too, but we don't know if it was an optimal strategy. Why does this kind of seem to work?
Well, think about it. There's always going to be two intervals. If you let n equal 6, Bella can choose 3, the midpoint. That's going to create two intervals from 0 to 2 point, or we could say 3, I guess, not inclusive, 2 actually. And then, or it's going to be from 4 not inclusive to 6 inclusive. Okay, so now think about this. If Bella chose 3, there's two intervals. If Jen has a choice in this interval, Bella has a matching choice in the other interval available. If Jen has no move over here, then she won't have a move over here. So as long as Bella does exactly what Jen does in the other interval created, if Jen leaves space like she did here for the second option, where Jen chose 1.49, leaving an open interval of 0 to 0.49, if she does that, Bella can do the same thing, so there will always be two choices left, one on the left and one on the right, at least two, right? Now, if Jen chose the blocker strategy, like we said, of 0.75 to eliminate this interval, then Bella eliminates the other interval and just consistently mirrors whatever Jen does. In this way, Bella will always win, and the answer is A.
All right, and this is the 2020 10B problem 17. There are 10 people standing equally spaced around a circle. Each person knows exactly 3 of the other 9 people. The 2 people standing next to her or him, as well as the person directly across the circle. Before we kind of progress, let's just kind of, make sense of this somehow. Let's make a circle. We'll just number them 1 through 10. So 2, 3, 4, 5, 6, and then that's got 4 here. There'll be 4 over here. 7, 8, 9, and 10. Okay. So the 2 people staying next. So 1 knows 10, 2, and 6. Right? 1 knows 10, 2, 6. Okay, let's go on. How many ways are there for the 10 people to split up into 5 pairs so that the members of each pair know each other? We should probably suspect some kind of casework here. The trick is, how do we know which, type of casework to do? We could do like how many left pairs there are, or how many people are paired with the person to their right. But I think what I'm going to go with is how many people are paired across from each other. Okay? So we'll call them cross pairs. Let's say that there are 0 cross pairs. This would be case 1. So 1 is not paired with 6, 2 is not with 7, 3 is not with 8 or anything. In this situation, 1 can only go to 2 or 10. And if 1 goes with 2, 3 will have to go with 4, 5 will have to go with 6, 7 with 8, and 9 with 10. So it kind of falls like a domino. So there's one way if 1 goes to his right to pair up, and one way if 1 goes to his 10 to pair up. There are 2 ways under that case. Let's go to case 2, 1 cross pair. Okay? So if I erase this 2 crossed out, and I've got 6 crossed out, 1 just pairs with 6, right? How many choices do I have for the 1 cross pair? I've got 5 choices, right? Now, after I've made that 1 cross pair, since 2 cannot go with 7, 3 with 8, 4 with 9, or 5 with 10, I can pair 2 with 3, 3 with 4, or 4 with 5. But if I pair 3 with 4, 2 has no one to pair with because we're not doing another cross pair. So we don't want to do 3 with 4, but we can do 2 with 3, and that automatically means 4 is going to go with 5. The same thing happens over here, 7 with 8 and 9 with 10. So once you've made your cross pair choice, all the other ways are forced. All the other pairings are forced. So this one actually has 5 total ways for it to occur based on the 5 choices you can make for 1 cross pair. What about 2 cross pairs? Let's again start with 1 and 6 as the first cross pair,
If I pair 2 with 7, you'll have 3 people in a row that cannot cross pair. And if 3 goes with 4, 5's not paired up. So I can't do 2 with 7. If I do 3 with 8, 2's going to be stuck with no one to pair up with. And the other mirror image of 3 is 4, then 5 will have no one to pair up with. And similarly, 5 is the mirror image of 2. So there actually is 0 ways for this to take place. Let's do case 4. What if there are 3 cross pairs? So if there's 3 cross pairs, again, if I do like 2 with 7 and 4 with 9, you're going to have 3 and 5 stuck. So I can't have 2 separate ones, right? Automatically, when I pair up one choice here, again, the first choice, 1 with 6, there'll be 4 people in between those 2 on the right. And I'm going to have to take 2 of those people to cross pair with 2 of them over here to make 3 total cross pairs. So I have to pick 2 of these numbers if 1 and 6 is one of the 5 cross pairs. Okay, so after I've made the 1 and 6 choice, if I take 2 and 3 both, right, 2 and 3 with 8 and 7, this works because now 4 can pair with 5 and 10 can pair with 9. I can't do 3 and 4 both because 2 and 5 will be stuck. I can do 4 and 5 both, crossing over with 10 and 9. And 3 and 2 both will be paired together along with 7 and 8 paired together. Right now, 2's with 7 and 3's with 8 to get our 3 cross pairs. So for this one, you're going to have 5 choices for the first cross pair. No, that won't work. What we actually have to have is 3 in a row. So 1 paired with 6, 2 with 7, 3 with 8. There has to be 3 in a row for this one to work. How many ways can I do 3 in a row? I can do 1, 2, and 3, 2, 3, and 4, 3, 4, and 5, 4, 5, and 6, and 5, 6, and 7. Make sure you go 6, 7, and 8. This is actually 1, 2, and 3. 1, 2, and 3 pairs with 6, 7, and 8. So it's the same one. Don't accidentally count twice. So we don't want those. There's 5 ways for us to have 3 cross pairs. Okay, next up we're going to go to case 5, 4 cross pairs. If you have 4 cross pairs, it should be really obvious you're going to have 2 people across from each other. They're not going to be next to each other, right? 4 with 9. Then 5 and 10 are stuck. They can't pair up, and it doesn't work. So it should be really clear there are 0 ways for that to occur. And finally, case 6, if I have all 5 cross pairs, there's only one way to do that. So you get one way, and you're going to get 2 plus 5 plus 5 plus 1, which is 13. Answer choice C.